Definition of PCB. The letters PCB stand for Printed Circuit Board. It is a thin board made of fiberglass, composite epoxy, or other laminate material. Conductive pathways are etched or printed onto the board, connecting different components on the PCB, such as transistor, resistors, and integrated circuits. Thermal expansion of PCB. A PCB will expand in length or width by 14 parts per million per Celsius degree. This means that if a PCB were 1 million inches long, it would expand by 14 inches for every Celsius degree of temperature increase. A PCB expands as it is heated and contracts as it is cooled. Structure of PCB. 1. It is a board base that is prepared for attaching electronic components. It is processed for supporting and wiring the surface-mounted and socket components. The board is made of a material that does not conduct electricity. Therefore, it can be fiberglass or plastic. A conductive material is utilized to attach the parts to the base. This material allows the electricity to travel from one part to another. Structure of PCB. 2. Some applications like computers require fine conductive traces. In such applications, PCBs are made by a photolithographic process. PCBs are particularly effective for high-speed analog circuits. However, in order to ensure good performance of audio circuits, great care is to be taken in the design and manufacture of PCBs. Any mistakes in the process can easily be avoided with a systematic approach. Applications of PCB. Bead is the interconnect pin expert. We supply high-quality interconnect pins to many of the world's leading OEMs and CMs. We offer a wide variety of standard solid wire, tubular, and end-to-end contact pins. Bead can also manufacture reliable insertion tooling for your insertion heads. Engineering, manufacturing, and processing capabilities allow us to design, tool, and produce custom interconnect pins very quickly and with minimum tooling charges. Circuit complexity in PCB. The decision as to how many layers the PCB should hold largely depends upon the complexity level of the circuits. The different types of PCB give an idea of the complexity level. Single-sided PCB circuit complexity. With single-sided PCB types, the circuit complexity level is low. Very simple consumer electronics are fabricated on single-sided PCBs. The designs used for this type of PCB include jumper wires, which ultimately stimulate the circuit to double-sided PCB. Usually, single-sided PCBs are used for circuits that carry low frequency. Besides this, complex designs can also be implemented through this type of PCB, but all this demands a deep understanding of the concepts. Double-sided PCB circuit complexity. The complexity level of circuits rises to a higher point in double-sided PCBs. With this type of PCB, highly fabricated materials are used. The double-sided boards are easier to route. This is because there are 2 layers of foil embedded on the board, and the signals can be routed by crossing traces on different layers. For perfect designing, it is always recommended that bottom layer should be devoted to ground plane, and the signals must get routed on the top layer. Multi-layer PCB circuit complexity. In comparison to single-sided and double-sided PCBs, multi-layer PCBs prove to be the best option in handling complex circuit designing tasks. The multi-layer boards provide real-time effectiveness for sensitive or high-speed designs. This is so because multi-layer boards are most suited for better routing for power and ground connections. Also, during connections, high-frequency noises can be avoided due to the distributed capacitance between the power and ground planes in the multi-layer boards. PCB making. PCBs generally available in the market are designed for common use of circuits. They are not particularly designed for any special circuit. Rather, they are available as copper-clad boards. It implies that the whole area of the board is coated with copper on both sides. When the track layout is designed by the user as per the circuit diagram, the remaining copper is removed by a process named etching. Once the unused copper is removed, the board is then cleaned. After cleaning, drilling of the relevant points is done. After the drilling, related components are soldered onto the board. Precautions to be taken with PCBs. All PCB containing equipment need to be checked regularly for signs of PCB leakage. If substantial leakage occurs, you should obtain the assistance of a specialist contractor immediately. In such an event, you should not do any work when there is a possibility that you may come into contact with PCBs, including dealing with broken PCBs, unless your employer has trained you and given you a safe procedure to follow. Precautions to be taken with PCBs continued. Because PCBs can easily pierce your skin, you should wear personal protective equipment if there is any possibility of contact with PCBs. All cuts and abrasions need to be covered with dressings before you put on your protective clothing. However, no material is completely impervious to PCBs. Characteristics of PCBs. Much of the electronic industry's PCB design, assembly and quality control follow standards published by the IPC organization. We can talk of through-hole technology, surface mount technology, circuit properties of PCB and materials. Laminates, copper thickness, and safety certification issues also need to be considered. Through-hole technology. The first PCBs used through-hole technology, mounting electronic components by leads inserted through holes on one side of the board and soldered onto copper traces on the other side. Boards may be single-sided with an unplanted component side, or more compact double-sided boards with components soldered on both sides. Horizontal installation of through-hole parts with two axial leads is done by bending the leads 90 degrees in the same direction, inserting the part in the board, soldering the leads, and trimming off the ends. Leads may be soldered either manually or by a wave soldering machine. Through-hole PCB technology almost completely replaced earlier electronics assembly techniques such as point-to-point construction. From the second generation of computers in the 1950s until surface mount technology became popular in the late 1980s, every component on a typical PCB was a through-hole component. Through-hole manufacture adds to board cost by requiring many holes to be drilled accurately and limits the available routing area for signal traces on layers immediately below the top layer on multi-layer boards, since the holes must pass through all layers to the opposite side. Surface mount technology. Surface mount technology emerged in the 1960s, gained momentum in the early 1980s, and became widely used by the mid-1990s. Components were mechanically redesigned to have small metal tabs or end caps that could be soldered directly onto the PCB surface instead of wire leads to pass through holes. Components became much smaller, and component placement on both sides of the board became more common than with through-hole mounting, allowing much smaller PCB assemblies with much higher circuit densities. Surface mounting lends itself well to a high degree of automation, reducing labor costs and greatly increasing production rates. Some wire-ended components, such as 1N4148 small signal switch diodes, are actually far more convenient than surface mount devices equivalents. Circuit properties of PCB. Each trace consists of a flat, narrow copper foil that remains after etching. The resistance determined by width and thickness of the traces must be sufficiently low for the conductor to carry the current. Power and ground traces may need to be wider than signal traces. In a multi-layer board, one entire layer may be mostly solid copper, which acts as a ground plane for shielding and power return. For microwave circuits, transmission lines can be laid out in the form of a strip line and microstrip with carefully controlled dimensions to assure a consistent impedance. In radio frequency and fast-switching circuits, the inductance and capacitance of the printed circuit board conductors become significant circuit elements, and that is usually undesirable. But they can be used as a deliberate part of the circuit design, obviating the need for additional discrete components. Materials. Excluding exotic products using special materials or processes, all printed circuit boards manufactured today can be built using the following two materials: laminates, copper-clad laminates. Copper thickness. PCB designers and fabricators often use heavy copper when designing and manufacturing circuit boards in order to increase current carrying capacity as well as resistance to thermal strains. Heavy copper-plated vias transfer heat to external heat sinks. IPC 2152 is a standard for determining current carrying capacity of printed circuit board traces. Product range of PCB. PCB product range includes double, single-sided, flexi, higher layer count multi-layer, controlled impedance, metal-backed, and copper plating on ceramics. Structure of single-sided PCBs. Single-sided PCBs are the simplest and the cheapest type of boards, with a single layer of copper on a rigid base material. Solder resist and indents can also be added. This type of PCB can be used for both through-hole and surface mount components. Structure of double-sided PCB. Double-sided PCB consists of two copper layers on a rigid base material. The two copper layers are not connected. Double-sided PCBs with plated through holes have two copper layers that can be connected by a copper-plated hole. Solder resist and indents can also be added. This type of PCB can be used for both through-hole and surface mount components. Flexi PCB. Benefits include solving interconnecting problems, reduction of weight, and reduction of space and reduced assembly costs. Flexible applications can be dynamic flexing or flex and stay applications. There are various types of flexi: single-sided flexi, double-sided flexi, and multi-layered flexi. Single-sided flexi. Single-sided flexible circuits are the simplest and therefore the cheapest, consisting of a single conductor layer on a flexible dielectric film with the option of a cover layer or semi-flexible liquid photo-imageable solder resist. Parts of the flexible circuits can be made more rigid by the use of additional stiffeners. Double-sided flexi. Double-sided flexible circuits consist of two copper layers with a dielectric layer in between, normally connected with plated through holes, with the option of cover layers or semi-flexible liquid photo-imageable solder resist. Parts of the flexible circuits can be made more rigid by the use of additional stiffeners. Multi-layered flexi. Multi-layer flexible circuits consist of three or more copper layers with a dielectric layer in between, normally connected with plated through holes, with the option of cover layers or semi-flexible liquid photo-imageable solder resist. Parts of the flexible can be made more rigid by the use of additional stiffeners. High layer count multilayer. Multilayer PCBs are boards with three or more copper layers. This is achieved by manufacturing the desired number of double-sided boards and bonding them together with glue. Standard processes are then followed to complete the board. Microwires connect holes through the whole board. When there are multiple layers of conductor patterns and you only require some of them to be connected, buried and blind wires can be used. Buried wires connect inner layers together but not to the surface layers. Blind wires connect one of the surface layers to one or more of the inner layer. Controlled impedance. Controlled impedance printed circuit boards are used across a broad range of applications to help ensure high signal integrity. Impedance depends on track width, space, and layer builds. This can be checked during manufacture. Metal-backed. Aluminum-backed PCBs are now being used in place of traditional PCBs for high-power LED applications. This is due to rapidly changing developments in LED technology, with brighter, more powerful LEDs coming onto the market almost daily. This raised a problem to designers and PCB manufacturers with large amounts of heat being generated by the components. The answer came along in the form of aluminum-backed PCBs with the use of thermally conductive pre-post between the copper and the aluminum. The thermal performance is 8 to 10 times better than a standard epoxy glass PCB. Plating on ceramics. Ceramic processing begins from sourcing the basic ceramic and includes copper plating, imaging, and etching. Surface plating different finishes like nickel, gold, silver, copper, tin, tin lead, and laser drill profiling. Cost of making PCB. Most PCBs, which are tailor-made for each circuit, are usually compact and generally wire-free. But many times people find the compact PCBs costly, though they are readily available for circuit connections. As an option, they can choose to make their own PCB, which may appear to be a cumbersome process, but actually proves to be a cost-effective approach. Generally, the required components needed to make a personal PCB are available at the nearby hardware store, and that too at a very reasonable cost. PCBs are commonly used in all but the simplest electronic products. They are required to be designed with an additional design effort that helps in laying out the circuit. Manufacturing the circuits with PCB is cheaper and faster in comparison to other wiring methods. One can easily make PCB as per the required design and circuit demands. All that is needed is the follow-up of a detailed and planned process. PCB fabrication. If you look at any complex circuit pattern of a PCB, you can easily get confused or somewhat puzzled at the design and creation. Mostly when you look at a finished PCB, you might feel the difficulty level embedded in the complex circuit pattern and mixture of surface mount and the whole components pretty high. The pattern symbolizes the difficulty and the time-consuming approach that demands specialized tools and expertise in working. However, the reality is different. Actually, fabricating a PCB is a relatively simple process. To attain success in creating your own printed circuit board, you need to follow the steps on screen. Generation of the schematic, placement and routing of the circuit board, generation of artwork, exposing and developing the resist layer, etching of the printed circuit board, PCB's tin plating, drilling and shaping the final structure. PCB making, a simple method. You begin the process through drawing a schematic of the circuit on the computer. This can be done by using suitable software. Once a schematic is designed, you can now design a PCB by using the required software. When the design is ready, take the printout of the design by using a laser printer. After this step, you can take the impression of the circuit on the copper-clad board. Once you're done with this, you can now remove the excess copper by the etching process. Basic circuit development on software. To draw a schematic of the circuit, a variety of software can be used. These are generally made available over the internet for free. Express SCH is one such software. The software will let you have a detailed schematic of the circuit. The detailed overview will further help in designing the required PCB without any extra hard efforts. To begin with, we can mark the components in the screenshot of the circuit drawn on the software. It can be seen from the diagram adjusted alongside. Marked icons. By following the task mentioned in the line starting from 1, you can learn to continue the process of developing the circuit. Let us discuss the tasks related to the marked components. This point is used to rotate the component as well as the text at right-angled degree. Also, it can be used to rotate the text. This point rotates the component by 90 degrees. With this marked position, one can find all the components. It is basically the components and symbol manager. With the fourth part named options, you can actually change the color and dimensions of the screen. Also, you can alter the grid spacing and other options. This marked point is a previous zoom option. It helps in resuming the previous screen shape. This option is named as Zoom to Fit option. Let us discuss some more tasks related to the marked components. It is Zoom Out option. It is Zoom In option. With this marked point, you can undo the previous action. This option allows you to save the file. This helps you in opening the saved file or a new file. This marked point is a general purpose pointer. It is basically the select and moving tool. Let us discuss some more tasks other than the main icons related to the marked components. If you wish to zoom any selected area, you can do so by this icon. This pointer allows placement of any component to any specific location. With this, you can place a signal or symbol level. For example, you can place symbol of power supply or ground. This icon helps in placing a wire in the circuit design. It helps in placing the connections. This icon is used to break the wire into two. It is actually used to place a corner in the wire. This icon disconnects a wire from component and helps in connecting it with the other. Some more tasks related to the marked components. This icon allows you to make a rectangle for a new customized component. This way you can make any component which is not available in the component library. This icon helps in adding a line into a customized component. With this icon, you can add a circle or arc in a new component. This marked icon helps in placing a new pin in the component. This icon aids in placing the text. This icon helps in snapping the grid. This option, when kept on, will allow the wires to move and make angles at specific gaps. Now we can make straight lines and designs. In case you need to make high precision angles in the circuit, you can do so by turning this icon off. Designing of PCB. After studying the steps discussed, you might become aware of the basic functions performed by several icons. Once you set the icons alive, you can easily get your design document without any extra effort. All you need to do is to follow the above steps in a chronological order, and you can have the PCB design ready with you. You can take the printout of the design, which can later be reflected on the copper-clad board. The designed PCB can then be finished by the etching process. Standard design specifications. Standard conductor width 0.005 inches, 0.125 millimeters. Minimum conductor width 0.002 inches, 0.05 millimeters. Standard conductor space 0.005 inches, 0.125 millimeters. Minimum conductor width 0.002 inches, 0.05 millimeters. Standard finish hole 0.10 millimeters, drilled 0.2 millimeters. Minimum finish hole 0.05 millimeters, drilled 0.1 millimeters. Maximum aspect ratio 16:1. Standard annular ring 0.005 inches, 0.125 millimeters. Minimum annular ring 0.003 inches, 0.076 millimeters, and number of layers 32. Lead times. Lead times can vary from a standard 15 days to express 24 hours depending on order specifications. Typically, single-sided PCBs take the least time. Grounding. Good grounding is a system-level design consideration. It should be planned into the product from the first conceptual design. The most important rule is separate grounding for analog and digital portions of circuitry. This is one of the simplest and most effective methods of noise suppression. One or more layers on multi-layer PCBs are usually devoted to ground planes. If the designer is not careful, the analog circuitry will be connected directly to these ground planes. In case of shorting of the analog and digital circuitry returns, auto routers respond accordingly and connect all of the grounds together, causing a disaster. Precautions. Precautions should be taken during design to suppress EMI level by prevention of the decrease of negative resistance. Also, due consideration should be given to these aspects. Pattern length on PCB, influence of patterns other than crystal oscillation circuit, shielding with field ground.